Today's problem is a really special one because it contains three powerful topics. One is trigonometry, and two is calculus, and third one is sequence and series, all in a single question. Let's look at the problem. We are given, let f of x equal to summation k equal to infinity 1 over 2 raised to the power of k tan x over 2 raised to the power of k. We need to find limit x tends to 0 x raised to the power of 2 f dash of x. So it looks a bit scary, but don't worry, once we understand the pattern, the entire problem becomes smooth and logical. By the end, we will see how simple and elegant the answer turns out to be. Let's begin this beautiful question. What they given f of x equal to summation k equal to infinity 1 over 2 raised to the power of k tan x over 2 raised to the power of k. Only we will take this tan x over 2 raised to the power of k. If we consider this x over 2 raised to the power of k as theta, then it becomes tan theta. This tan theta, we can write this as sin theta over cos theta. If you multiply and divide it by sin theta, that is going to be sin square theta over cos theta sin theta. For this numerator sin square theta, if you add and subtract with cos square theta, what we are going to do? We are adding 1 cos square theta and we are subtracting 1 cos square theta and write the sin square theta. So this plus cos square theta and minus sin square theta gets cancelled, so we left only sin square theta. Cos square theta. So here we have a minus and here we have a plus. So let's take minus as common. So if we take minus as common, so what we left only cos square theta, then minus sin square theta, isn't it? See, minus into minus plus sin square theta. Now see here, cos square theta minus sin square theta is, which is nothing but cos 2 theta. At denominator we have cos theta sin theta. At numerator we have a 2 terms. So this denominator, it goes for the 2 terms, so divide it individually. Here 1 cos square theta and here cos theta gets cancelled. So we left only cos theta over sin theta. And cos theta over sin theta, we know that it is a cot theta. So let's simply write this as cot theta. For the second term, if you do multiply and divide it by 2, at denominator, now we have 2 cos theta sin theta, which is nothing but sin 2 theta. Let's write this as sin 2 theta. Now observe here, cos 2 theta over sin 2 theta, which is nothing but cot 2 theta. So finally, instead of tan theta, we can write this as cot theta minus 2 cot 2 theta. So now we are going to substitute this identity in our summation. We consider theta as x over 2 raised to the power of k. So now substitute theta as x over 2 raised to the power of k. So tan x over 2 raised to the power of k, that is equal to cot x over 2 raised to the power of k minus 2 cot 2 times x over 2 raised to the power of k. This is the theta value for this second term. Here we have a 2x over 2 raised to the power of k. This we can write as x over 2 raised to the power of k minus 1. Isn't it? So let's write 2x over 2 raised to the power of k, we can write it as x over 2 raised to the power of k minus 1. We have a tan x over 2 raised to the power of k. We simplify this. Now you have to take 1 over 2 raised to the power of k. So let's multiply both sides by 1 over 2 raised to the power of k. So what we are going to get, 1 over 2 raised to the power of k cot x over 2 raised to the power of k, that is the first term, minus, here observe this 2 over 2 raised to the power of k. This one also we can write it as 1 over 2 raised to the power of k minus 1. So then what we left, cot x over 2 raised to the power of k minus 1. So that is nothing but 1 over 2 raised to the power of k tan x over 2 raised to the power of k value. We finish this 1 over 2 raised to the power of k tan x over 2 raised to the power of k. So now we need to take this summation k equal to 1 to infinity. That is our f of x. Now you have to take summation k equal to 1 to infinity. This is a telescoping series. So let's write out the first few terms. So let's substitute k equal to 1. What we have 1 over 2 raised to the power of k, that means 1 over 2 raised to the power of 1, which is nothing but 2 times cot x over 2 raised to the power of 1, which is nothing but 2, minus 1 over 2 raised to the power of k we are taking as 1. So that's why 1 minus 1, which is 0. So anything power 0 is nothing but only 1. Then cot x over 2 raised to the power of 1 minus 1, that is nothing but 2 raised to the power of 0. Anything power 0, the value is 1. So we left only minus cot x. So for the k equal to 1, 1 over 2, cot x over 2 minus cot x. Now substitute k as 2. So if you substitute k as 2, then we are going to get 1 over 2 raised to the power of 2 times cot x over 2 raised to the power of 2 minus 1 over 2 raised to the power of k minus 1. We are substituting k as 2. So 2 minus 1 is nothing but 1. 2 raised to the power of 1 is nothing but only 2 cot x over 2 raised to the power of, we are substituting k as 2. So that is 2 minus 1, which is nothing but 1 cot x over 2. Here 1 over 2 raised to the power of 2 is nothing but 4 times cot of x over 2 raised to the power of 2 is nothing but 4. So for the k equal to 2, we are going to get 1 over 4 cot x over 4 minus 1 over 2 cot x over 2. Now let's substitute k as 3. We are going to get 1 over 2 raised to the power of 3 is nothing but 8 cot x over 2 raised to the power of 3 is nothing but 8 minus 1 over 2 raised to the power of 3 minus 1 is nothing but 2. So 2 raised to the power of 2 is nothing but 4 cot x over 4. So this is for the k equal to 3. So let's write here 1 over 8 cot x over 8 minus 1 over 4 cot x over 4. So up to so on, if you take k as n, so then we are going to left 1 over 2 raised to the power of n cot x over 2 raised to the power of n minus 1 over 2 raised to the power of n minus 1 cot x over 2 raised to the power of n minus 1. Now observe that all intermediate terms. 1 over 2 cos x over 2, this is plus value, and here we have a minus value. These two are gets cancelled. And again 1 over 4 cot x over 4 plus 1, and here minus term gets cancelled. Like that all the intermediate terms gets cancelled. So we left only minus cot x plus. So what we left? We left only this 1 over 2 raised to the power of n cot x over 2 raised to the power of n. This is nothing but f of x. Finally f of x equal to, so what we left? We left 1 over 2 raised to the power of n cot x over 2 raised to the power of n minus cot x. So this we got. So this is up to only k equal to n terms, but the given summation k equal to 1 to infinity. So here we need to take limit n tends to infinity. So that's why I am going to take limit here. Limit n tends to infinity 1 over 2 raised to the power of n cot x over 2 raised to the power of n minus cot x. Let us assume h as x over 2 raised to the power of n. So here we have a 1 over 2 raised to the power of n. So let's find out that. If you divide both sides by x, then we are going to get this x and x cancel. So we left only 1 over 2 raised to the power of n is nothing but h over x. So here n tends to infinity. If n tends to infinity, so the h value tends to 0. So we need to take f of x as limit h tends to 0. This 1 over 2 raised to the power of n is nothing but h over x. H over x cot x over 2 raised to the power of n is nothing but h. Let's take h minus cot x. And here you need to evaluate only the first term, because we are doing with respect to the limit n tends to infinity. In the second term, we don't have n value. That's why let's leave the cot x as it is. Only evaluate this first term. Limit h tends to 0. We are doing with respect to h. So that's why x take it as front. So 1 over x times limit h tends to 0. H cot h minus cot x. And we know that limit h tends to 0. H cot h, the value is 1. So the first term, the value is 1. So let's write only 1 minus what we left, cot x. So finally we got the f of x value. So f of x, the value is 1 over x minus cot x. Now let's take the question. What is our question? We need to find out limit x tends to 0, x tends to the power of 2, derivative of f of x. Here what we do, first do the derivative of this f of x, then multiply with the x power 2, then take the limit. So that's why first do the derivative of x. So what is the derivative of 1 over x? Minus 1 over x raised to the power of 2 minus, what is derivative of cot x? Which is minus cosecant square x. So here minus into minus plus. So finally we got derivative of x is minus 1 over x raised to the power of 2 plus cosecant square x. We are done with this f derivative of x. Now we need to take x raised to the power of 2. So let's take x raised to the power of 2. That means multiply both sides by x raised to the power of 2. Here x raised to the power of 2 and here x raised to the power of gets cancelled. So we left only minus 1 here. This cosecant square x we can write it like 1 over sine square x. X power 2 over sine square x we can write it as x over sine x whole raised to the power of 2. So now we did with this x raised to power of 2 f derivative of x. Now we need to take limit x tends to 0. So let's take limit x tends to 0 x power 2 f derivative of x. So that is equal to limit x tends to 0 minus 1 plus limit x tends to 0 x over sin x whole raised to power of 2. For the first term we left only minus 1. In the second term, limit x tends to 0 x over sin x, the value is 1. So this value is 1 and we have a power 2. So 1 power 2 is nothing but only 1. Plus 1 the value is 0. So finally limit x tends to 0 x raised to power of 2 f derivative of x, the value is 0. So like that you have to simplify step by step. Then you can get the answer very easily. That's it for today's video. If they like the content, please like, share and subscribe my channel. Thank you for watching.